All right, so in our last session, we saw how the stomach churned our food into that acidic slurry we call chyme. But you know what? That was just the opening act. Now we're heading into the main event of digestion, a pretty wild journey through the small intestine.
So that chyme is ready to go, but the real work is just starting. Here's a question for you. Where does almost all the good stuff, I'm talking about 90% of all the nutrients, actually get absorbed into your body? Well, it all happens right here in the small intestine.
So here's our game plan for today. First, we're going to meet the small intestine itself. Then, we'll uncover its incredible superpower for absorption. After that, we'll see how some helper organs show up to the party, tune into the amazing chemical symphony that takes place, and finally, we'll see how all those nutrients get delivered.
Okay, first things first. Let's get properly introduced to this amazing organ. And right off the bat, we've got a bit of a puzzle, starting with its name. Why on earth do we call it the small intestine when this thing is, on average, a whopping 10 to 16 feet long? Well, the name has nothing to do with length. It's actually all about its diameter, which is much narrower than the large intestines. So yeah, it's about girth, not length. Now, this super long tube is split into 3 different zones. The journey for chyme kicks off in the duodenum. It's the shortest part, but it's where chemical digestion goes into absolute overdrive. From there, it moves into the jejunum, which is the real powerhouse of nutrient absorption. And the final stretch is through the ileum, the longest section, which is there to finish the job and absorb whatever is left. Okay, so how in the world does this one organ manage to absorb 90% of our nutrients? The secret is all about maximizing surface area. But how do you cram a huge surface area into your abdomen? Well, the answer is just a stunning piece of biological engineering.
The intestine is a master of maximizing its surface area, and it does it on 3 different levels. First, the inner lining isn't smooth. It has these large, permanent folds. Think of them like speed bumps. Second, these folds are completely carpeted with millions of tiny, finger-like projections called villi. But it doesn't stop there. Third, if you could zoom in on the individual cells on those villi, you'd see they have their own, even tinier, hair-like projections called microvilli. And altogether, these microvilli form what we call the brush border.
So when you add up all those folds on top of folds on top of folds, what kind of surface area are we actually talking about? Well, it's about 200 square meters.
You heard that right. That is literally the surface area of a full-size tennis court, all folded up and packed inside your body. This absolutely massive surface area is the whole secret to the small intestine's incredible efficiency. It makes sure that no nutrient goes unabsorbed.
Now, as amazing as the small intestine is, it doesn't do all this heavy lifting alone. To handle the intense chemistry of digestion, it needs to call in some serious backup, what we call the accessory organs. Let's meet the support team. First, you've got the pancreas, which whips up a cocktail of powerful enzymes and, this is critical, a substance to neutralize all that stomach acid. Then there's the liver, the body's main chemical factory, which produces a substance called bile. And finally, you have the gallbladder, a little storage pouch that holds onto that bile and concentrates it until the time is right.
Okay, so let's zoom in on what happens inside the duodenum, because it's like a perfectly coordinated chemical symphony. You've got hormones acting as the conductors, and enzymes and bile playing all the instruments.
So problem number 1, that chyme coming from the stomach is super acidic. It would literally destroy the lining of the intestine. The solution? As soon as that acid hits the duodenum, the intestine releases a hormone called secretin. Secretin is the signal that tells the pancreas, hey, release bicarbonate now. Bicarbonate is basically nature's antacid, and it neutralizes the chyme, making everything safe. Problem number 2, fat. You know how oil and water don't mix? Well, that makes fat really hard for our water-based enzymes to digest. The solution? Bile. Bile works just like dish soap. It takes big globs of fat and breaks them down into tiny little droplets. This process is called emulsification, and it gives the enzymes way more surface area to attack the fat.
So who's the main conductor for all this? It's another hormone, called CCK for short. When your body detects fats and proteins arriving, it releases CCK, and this hormone is an expert multitasker. First, it tells the gallbladder, squeeze, release that bile. Then it tells the pancreas, time to release your digestive enzymes. And at the very same time, it sends a message back to the stomach, telling it to slow down, which gives the small intestine enough time to do its job properly.
So let's just pull all that teamwork together for a second.
You've got the pancreas sending in enzymes to break down starches, fats, and proteins. You have the liver and gallbladder providing the bile to handle the fats. And then, the small intestine itself has its own set of finishing enzymes right there at the brush border. Things like peptidase and sucrase that do the final little snips to get nutrients into their smallest absorbable form.
So everything's been broken down into its tiniest components: amino acids, simple sugars, fatty acids, you name it. It's time for the final crucial step, actually getting these nutrients out of the intestine and delivered to the rest of the body.
Once the nutrients pass into the intestinal cells, they get sorted onto two different highways. Most of them, the water-soluble ones, like sugars and amino acids, go straight into the tiny blood vessels, the capillaries. From there, all that blood goes directly to the liver for processing. But most of the fats are too big to get into those tiny capillaries, so instead, they get packaged up and enter special lymphatic vessels called lacteals. This route bypasses the liver at first and delivers the fats more indirectly into the bloodstream.
You know, this whole incredible process really highlights a super important concept in nutrition, and that's bioavailability. See, it's not just about what's in your food, it's about how much of that nutrient your body can actually break down, absorb, and put to use. That is the real measure of success for your digestive system. The whole point of this tennis court-sized surface area and this chemical symphony is to maximize the bioavailability of everything you eat.
And with that, the small intestine's job is pretty much done. It has masterfully extracted almost every last usable nutrient from our food. But the digestive journey isn't quite over. What about all the stuff that couldn't be digested, like fiber, along with leftover water and other waste? Well, that's a job for our next and final stop, the large intestine.